can I cool down my house? By making use of groundwater with almost no additional energy and no high costs. In the summer days I'm watering my garden with groundwater of 12 degrees. How awesome would it be if we can make use of that cold energy first before using it? And this is the project that I'm most passionate about for already a really long time. And now it's time to really build it. Let's see if it actually works and how efficient it can be. Let's really build something this week. Today is actually not the best day to showcase this project. It's cloudy, it's rainy and the temperatures are quite comfortable. But in summer the temperatures inside my house can get really hot, up to 30 degrees Celsius. And while I already have shutters to block direct sunlight, the floor will get really hot too. And also when the sun disappeared, the floor is still providing heat to the house. Cooling down a house via the floor is already a proven concept. And modern heat pumps are doing exactly that. But the disadvantage is they're still using a lot of power, energy. And in the summer I'm already watering the garden with groundwater, which is about 12 degrees throughout the year. And at water of 12 degrees is directly flooded on the garden. So in my idea, a lot of cold energy is wasted in that way. It started me thinking, can I make use of that cold energy in an efficient way to cool down my house? And I searched around a bit and I was not able to find much. So I wanted to experiment with this by myself. And I did some calculations how much cold energy there is in the groundwater that I can potentially use. And that's what this experiment is about. In this video I will see how efficient I can make use of the cold energy in groundwater to cool down my house in the summer days. Not making use of expensive equipment, just some do-it-yourself parts. Stuff that I have laying around and some cheap parts that I ordered for this project. And at first I thought I'll just connect everything to my floor heating and see how it works out. But doing the modifications on my existing floor heating system has quite some impact. And if the concept is not working, it doesn't make sense to continue with it. So first I wanted to make a proof of concept. And if the test results are promising, we'll connect it to the existing floor heating system in the house and see how it behaves in the real world situation. And to do some proper testing, I created this proof of concept test setup. This is the proof of concept setup to test if the idea is working at all. Yeah, I had something more spectacular in mind. But it is what it is, it's just a proof of concept. Let me explain you some more of the details here. And because there can be iron and contamination in the groundwater, you don't want to flow that through your floor heating system. So we're making use of two separate circuits. One circuit for the groundwater, a buffer that contains the 12 degrees groundwater, which will heat up slowly. And the other circuit will be the floor heating system. For example, with 24 degrees water in it, when the floor is around 25-26 degrees on the hot summer days, when it's 30 degrees in the house. And there is a quite big plate heat exchanger in the middle. So my idea was to flow the 12 degrees groundwater to one side and the 24 degrees water from the floor heating system to the other side. And then see how efficient we can cool down the house with it. And my first test is really simple. I will run both of the pumps at 12 volt so that they can run on maximum power. And one of the benefits that I have in mind of this system for later is that you can control both of the flows separately. And by controlling the flow, we can impact the heat transfer that takes place. So if we increase the cold water flow of the groundwater versus the water of the floor heating part, we can realize a lower temperature that goes to the floor. So if this cools really efficient, we can prevent that a temperature of lower than like 18 degrees goes to the floor, which can cause condensation, which we don't want. But let's first run both of the pumps at 12 volt and do some testing and see what the temperatures are and the efficiency that we can realize. It's quite windy, so I hope that the sound is at least acceptable. But we can do a first test run, so I'm really curious what this will do. To just as a simulation, I have the big buffer with some groundwater. It's 12 degrees. So that's our inflow of the groundwater. And we have a small reservoir that will simulate the floor heating system. So the water there is about 24-25 degrees. I think that's a good starting point for a test. And yeah, let's start and see what it is. And there is a screen capture running that's capturing the in and outflow temperatures. So I'm really curious what will happen. There is water flowing on both of the circuits now. The reservoir that is simulating the floor heating system, and the bigger reservoir that we will use for the groundwater. And let's see what the inflow and outflow temperatures are now. We see that there is a floor water inflow of 24 degrees, and the groundwater is now 14. So it's not the starting temperature of 12, but the floor water outflow is 18 degrees, and that's exactly what we want, because we don't want to cool the floor too much. And this is quite awesome, because the groundwater inflow is 14 degrees, 14.5 now, and after it exchanged its cold energy with the floor, it's about 20 degrees. So that's really nice. We're now cooling down the water of like 23 to about 18. And of course it's just a simple proof of concept. The surface is of course warmer than at the bottom. So I will just mix it a bit. And I guess we also will see that in the temperature in the charts. But this is really promising. And I didn't give really insight in the flow, in the amount of liters per minute or per hour. So that's something that we will figure out. And as some simple testing, I will just measure with a bucket how much water that we have now in a minute. But the next step is to have some nice flow meters in the circuit to see exactly what is happening. And then we can also calculate the cooling capacity. And I don't know if I'm surprised to see those numbers, because I already did some calculations before starting this project. But still, that was on paper. And this is in real world. So I'm really happy to see those numbers, those results, because those are really rough tests. I'm using a reservoir for which I don't know exactly how much liters that are in. And I also don't know how much liters of cold water that I did in the reservoir. But if we have some more details there, we can do some better calculations and have clear insight in how efficient it is running and what to expect from it if we connect it to the floor heating system in the house. Let's do a rough test so that we at least have a little bit of an idea what the water flow is at the moment. On this side it's about 23 seconds per 4 liters of water. And I'm curious if the other circuit is giving the same water flow. So I'll also measure that. Yeah. That's also around 24 seconds per 4 liter. So we can conclude that the water flows for both circuits are the same. And we can use that as input to do some further analysis. There's even more wind than yesterday, but I really wanted to do this outro also outside. So I hope that the sound is acceptable with the wind that we have now. Let's evaluate the proof of concept. And as already said, this is a project that I'm most excited about. It combines so many things that I'm really passionate about. Technology, energy efficiency, creativity, automation, increasing the living comfort in my house. For me, this is a project where it all comes together. I really like it. So let's see where we are so far. We have a water flow of around 600 liters an hour. And we saw a quite efficient heat transfer taking place between the groundwater and the simulated floor heating system. And now the interesting part here. Like on a sunny day, I'm watering the garden for like a few hours. And that's maybe 4,000 liters of water. That's 4,000 liters carrying cold energy that otherwise would be wasted completely. And as for the electricity consumption, I don't have clear numbers. But let's say that it's about a kilowatt or something for filling up the reservoir and running the pumps. So considering the amount of cold energy that we get back for that, that's very promising. And honestly, for the money that I've spent on this project so far, I'm already really happy. I really liked it to see my idea, the concept that I had in mind, becoming to life and really working in the real world. But still there are some big questions, of course. Like, would this system be capable to cool down my complete house? The results look promising, but I still need to figure out quite some things. One of the most important things that I still need to figure out is how efficiently I can use the cold energy that is stored in a tank. Because my idea was to get the 12 degrees of groundwater, have it in a buffer, and let it slowly transfer its cold energy to the floor heating system, till it reaches about 20 degrees. And that's one of the most awesome things here. We're not wasting any water. At the moment that the groundwater of 12 degrees is heated up till 20 degrees, we'll water the garden with it, which otherwise also happened, but then with the cold water. And maybe this is even better for the garden, to water it with like 20 degrees than 12 degrees. But there are also some practical questions here. Like the groundwater. Although I have filters in place, it's still groundwater with some iron in it. And the plate heat exchanger that I have, it's a semi-professional one, but it's not really for this sort of use. So one of the things that I need to figure out is, do I need to clean the water even more? Or do I need to make use of a professional heat exchanger that can be opened when needed to clean it? Or would it be more efficient to add additional filters, filtering out the iron? Those are some questions for the next phase. Now the proof of concept works. I first want to connect it to my floor heating system in the house as a basic setup, to see if it has enough capacity to cool the entire house and see what other challenges that pop up. And if that also works, I want to automate the whole system so that the floor always gets a controlled temperature and that the buffer is refreshed automatically when it hits the threshold temperature, and that it waters the garden with the water that is heated up. And the system will fill itself with fresh, cold groundwater, ready for the next cycle. And of course I want the buffer tank as insulated as possible. So maybe I bury it in the ground. It's out of sight and it's making use of the insulation already available there from the surrounding soil. And I have way more ideas to optimize this system. Maybe making use of the low tariffs that I sometimes have throughout the days. But that's something for later. Let's first have a basic setup running, attached to the house, and see how that works out. And that's why I'm so passionate about those projects. In my mind they sound really logical, but when I'm searching I cannot find that much. So what is the reason that other people are not doing that? I guess there should be a good reason, right? But as I was not able to find any setups like this, I thought, let's build it and see what we find. And now that I built the first version of this, I'm even more enthusiastic to see how will it work when I connect it to the house. I find it amazing what can be achieved with some creativity, curiosity and the willingness to just experiment. There's always the risk that things fail, but how awesome is it if things work out as expected, like this one? And if I've overlooked things, or you have ideas how I can make this better, please share them with me, contact me and let me know. This was the proof of concept. In part 2 I'll connect it to the actual floor and the heating system in my house and see how it works in the real world. If you like projects like this, then take a look at my other videos. In the meantime there is a bit of variety in topics and maybe that's fun to see as well. If you found this useful, interesting or just fun to watch, then consider becoming a subscriber and help me in growing the channel. I'm still a beginning content creator, trying to find my way around and spending as much time as possible on cool and fun projects like this. And especially for this one, about the floor cooling system. I'm already working on part 2. So please follow me in the journey. And if you're as curious as I am about how this will work in the real world on my house, then keep an eye on the next video. I'm already working on that. And I hope that it will be online in a week, maybe 2 weeks. So that we can actually see if it works as expected. For now, this was Forest Guy Builds. I'm John and I hope to see you in part 2. Keep it cool this summer.